Hey guys, in this video tutorial we'll be covering how to use the Galapagos component in Grasshopper. Now the very first thing I should mention, just to clear things up, is that it actually does come with Grasshopper itself. You don't need to install a plugin or anything like that. If you just go to the Parameters tab and make sure that you have, I think, just to be safe, Show Obscure under View. You'll notice on the very far right there is a component called Galapagos. So you click on that and click here to create it. Or you can double click and type in GAL and it'll turn up as the very first option, Galapagos. Now the very first thing as well I should say about Galapagos itself is that it's an evolutionary solver, which means it tries to get a better solution over time on its own. Once you give it two things: a list of genes, which is sliders like this, a bunch of sliders like that, as many as you want, and a special thing called a fitness function, which is used to tell Galapagos how good one setup of your sliders is compared to another setup of your sliders. Because what Galapagos does is it just slightly changes your sliders over time and finds out, using this fitness function, which setup is better, and then goes with that. Now I won't actually get into how evolution itself works to produce a better solution, but what I will be telling you is just how to use Galapagos. Just enough information so that you can set it up and run it and get something happening in your own model. So, very first thing, create the Galapagos component. And now what you need to do is define the genome parameter, which is the set of sliders that you connect up to Galapagos. So you can have as many sliders as you want. I'll just copy and paste a bunch here to make an example. You can give it as many sliders as you want and click and drag to connect them up. Now you'll notice that it doesn't click and drag from the slider up to genome. It does not want to connect. It's because Galapagos is a special component that you have to click and drag from it instead. And this red line will come out of genome and then snap onto the corner or the side of the parameter, the slider. So you can click and drag manually like this, and then shift click and drag to attach multiple ones. So you'll see there's now two arrows coming out when I select Galapagos. But that can be a little bit tedious. You can also, by the way, hold Control and click drag to disconnect it. So now this middle one here has been disconnected. But this can get a little bit tedious. So they added a few little things to make it faster to add the sliders that you want to Galapagos. So one option is to right click Genome and click All Sliders, and that will connect all the sliders in your Grasshopper script to Galapagos. Now for a small script, I think that's reasonable enough. That could be what you want, but I think you guys might end up with reasonably large scripts with maybe, I don't know, 10 or more sliders in it. So the easiest way for you guys to do it, let me just quickly disconnect all of these. I'll just delete Galapagos and then add it again, just to make that effectively deleting the links. The way that might be most useful to you guys is to select multiple sliders by holding Shift and clicking on different sliders, and then right click on Genome and click Selected Sliders, and that will connect only the sliders that you have selected at that point in time. So that covers most of what you'll need to know about the genome. The final thing I'll say is that Galapagos tends to work best with fewer sliders connected up to it. Without getting into too much detail, it just gets harder for Galapagos to to make a solution better if you have more sliders. So I'd recommend a maximum of maybe 6 or 7 sliders total, really. You don't need to have all that many hooked up, because it does become a little bit harder, as I said, for Galapagos to find a good solution. Now, onto this thing that I mentioned before called the fitness function, which I'll explain by saying it takes the model that you've produced. It should take the model that you've produced, analyze it in some way to get information about it as numbers. So that could be things like area, size, length. It could be maybe a number of random points that you've put in. It could be anything that produces a number that you can work with. And then it takes that, does some little mathsy operation on it, whatever you want to make it figure out what makes your model good compared to another setup of that model. So what I've done is I've created a couple of little examples here to show. So this one here takes a curve, a simple curve defined by 3 points here that you can see in the right hand panel just over here. You can move that curve around, and then it has a point defined by 2 sliders. Now I would have defined this point, by the way, using this MD slider, but Galapagos doesn't currently hook up to MD sliders as a genome, so you have to individually make these 2 points. These two numbers become a point over here, which is a bit inconvenient, but there you go. So yeah, what this script does is it first of all creates this curve, creates this point that you can move around, and then what I do with this fitness function is I tell Galapagos to make this point move as close as possible to this curve. So this point can end up almost anywhere on this curve, as long as it's as close to it as possible. Now the way I do that is I take the point and the curve out of this model that I've generated here. So this is all the visuals, by the way, should be going on in here. No visuals, nothing generated in your model should ever be happening in your fitness function. You should only take what you've been generating here in this section of your script, processing it in the fitness function to get some number. Okay, so I take the point here and the curve, and I use this little component here that measures the distance between the point and the curve. And then here I measure the total distance between this point and this curve to get a number. So I'll just give you a quick example of how this script will end up running. So I'll show you that I've connected up the genome. I've already connected it up to these 2 sliders here. So when I double click the Galapagos component, a little window will appear, and I'll right click and drag to move back over to the sliders so you can see them changing over time. And what we'll do is we'll say, okay, this fitness number, the number that we passed in over here, this one here connected up. By the way, you connect it by clicking and dragging from fitness to the number. Again, it's like the genome, you can't click and drag from number up there, it just won't connect. So what we want here, the one value that you'll really want to pay attention to is the fitness, which you'll want to either maximize, so increase over time, or minimize and decrease it over time. So this number that you pass in is the fitness. So Galapagos will try to increase it or decrease it depending which one of these 2 options you click to select. So at the moment we're measuring distance and we want it to get closer, so we want it to get smaller over time, so we're minimizing it. So now click on the Solvers tab, and I'll move back over to show the sliders, and I'll click Start Solver. And what it'll do is by default, it'll only show the best solution it's found in the viewport. As you can see here, these sliders are going crazy. It's actually running through, for each of these numbers that you see appearing here, it's running through 50 different setups of these sliders, 50 for each of these numbers. So these are going very, very fast, and you're only seeing the very best solution in the viewport. If you want to see all the solutions that it's trying, you click this option here, Display All Genomes in the Rhino viewport. Now this will make your script run a little bit slower. The Galapagos component will be a little bit slower because this visualization actually takes a little bit of time to show. So ideally you'll just be showing the best option so far in the Rhino viewport. So now this looks like it's gotten a pretty good solution, so I'll just click Stop Solver. Oh, it stopped it for me already, so that's good. And what I'll show you as well is this little list here is a list of genomes in order of the fitness number that they were all given. So this is the current, this is what's called the 66th generation, the 66th attempt at trying to get a very good solution. And there are, I think, 50 options or something like that. I'm not going to count them, that'll take a little too long. And yeah, so it's ordered from what Galapagos thinks is the best solution according to your fitness function to the current generation's worst solution. Now what you can do is you can click on these individually and click Reinstate, and that will cause it, see there, it'll change these sliders to whatever this particular genome's slider setup was. So it'll let you see what it had for that particular option. So if you run Galapagos and you get a terrible looking model as the final result, you can actually just look through this list and go, okay, maybe this one's better, or maybe that one's better. So you can go with a suboptimal model that to you just looks better. This is where it becomes a designer's tool, where you can actually select yourself what the better option is. Now beyond that, you can actually click up here and change the generation you're looking at. So every time I click a different number here, you get a different selection of genes here to have a look at. So let's go back a while to number 27. And we'll pick, I don't know, one that's down near the bottom, see how much it changes. Select that, click Reinstate, and okay, very small change. What about this one? Pretty much the same. Yeah, so depending how complex your model is as well, you can end up with very vastly different options under here. Now, this one example here is pretty straightforward, and what I've done here as well is I followed a general sort of layout of how you would make your Grasshopper script. You'd have all your inputs ideally on the very far left, then all of your model generation happening here, and then the moment you add a Galapagos component, you end up with another step to the whole process, which is an analysis after you generate your model, and then that produces your one number. Now I've got another example here that gets a little bit more complex for you. Let's see, I think this one is it. There we go. So what this one does, first of all, it uses a lot of genes. Let me select the Galapagos component to highlight what it's connected to. Note as well that I've got the same layout: input, generation, and then analysis. So I've hooked it up to a ton of sliders here. So remember what I said, I like to limit it to something like 6 or 7 sliders, otherwise it has a bit of trouble. So we know that this will take a while to find a good solution. It won't fail to find a good solution necessarily, it'll just take a while, much longer than if we just deleted it, even removed one of these points. It would go much faster. What I've got it doing here is generating one or as few surfaces as possible. Given a bunch of rectangles here, it combines them together and then finds out the total area that they cover. And what I've got this fitness function doing is taking that surface, the final surface here, measuring the area of it, adding that all together to get one number, and then using that as the fitness function. So what happens now, if we double click here, we'll go to solvers. Now we've got it minimizing this, so it's minimizing the area. It's trying to reduce the total area. So if we click Start Solver, and I'll just move over here and show you the sliders going crazy, you'll notice that these squares start to jostle and get closer and closer and closer together. Now, to us, the obvious best solution is when all the squares are in exactly the same spot. And that will make the total area as small as possible, because it won't be 2 squares or whatever. It'll just be 1. So we'll let it run a little bit, and we'll see that it's approaching a reasonably good solution here. Now, what you'll see as well is, like I said, it's having a little bit of trouble getting the best possible solution here. It's somewhat stuck. It doesn't, because what happens is when it tries to change one slider, it actually ends up trying to change most of them in one hit. And a lot of the time that ends up not working well. Like, you end up with 10 good sliders being changed to make a small improvement in one bad slider. So a lot of the time it just doesn't want to make that change to fix the final part. So here we go, very, very close to a solution. And as you can see, it's getting up to a very large number of generations here. You'll usually find that you'll run up to like generation maybe 100 and get the kind of solution that you are looking for. So you can just sit here and let it do its own thing, or if you get a little bit bored or you find it's already at a good solution, you can click Stop Solver, just up there. Now, so this is just another little demo of how Galapagos can work. Now, the next thing that I wanted to show you was a slightly more complex example of a model generated. I'm still using that base idea of having these squares all added together, but now what I'm adding to that is a little bit more complexity in the model. I'm now making pulling each of these squares up, extruding them upwards to different heights that I think I've got Galapagos controlling. Yes, I do. I'll just select Galapagos so you can see what it's controlling. So these are the individual heights you can see going up and down there. And you can think of this, I mean, very quickly this starts looking somewhat like a building form, So you can end up with some fairly simple models that you can nonetheless let Galapagos get its hooks into. So all I've done here is I've taken these rectangles and extruded them and combined them into one solid using this solid union. If or it could be more than one solid, you know, if they're not touching, but that's a thing for Grasshopper to figure out. So now what I've done here is something a little bit more interesting than the fitness functions from before. Where a fitness function and where Galapagos starts actually getting useful and interesting is when you have two competing criteria battling against one another for precedence in the model. So in this case, what I've got is I've measured the total volume of the model against the total surface area of the model. So what I'm trying to do here with this little bit of maths, I'm saying I want a bigger volume, but I want a smaller surface area. So hopefully it's fairly straightforward to realize that usually when you end up with a bigger volume, you'll also get a bigger surface area. So in that sense, these two criteria are automatically conflicting. So, by the way I made them conflict like that is I've brought them together here, and normally if you want them to both be bigger, you would say A plus B. But because I want B, this bit, to be smaller, I've said A minus B. So we're subtracting the one that we want to get smaller. And that's a thing that you can do generally with your analysis. If you want a thing to get smaller, you subtract it, and if you want it to get bigger, you add it. And that can be a handy little thing to do at times. So I'll run this now and we'll see what it does. So first of all, we want to make sure that I think this is what we want, maximizing. We'll see what happens. And we'll click Start Solver. Now this will run a little bit slower compared to before. So right off the bat it's shown what I wanted to show. So I guess I can stop the solver fairly quickly. I'll let it run through a few generations and then I'll show you what I was talking about. Alright, I'll stop solver. So here you'll see that it's hit 0 a few times. And if I click reinstate, there's actually no model being generated, it seems. It's only got the rectangles, but where's the height? Where are the building shapes and the volumes, right? There's no surface area, there's no volume for it to be using that we can see. Now the reason for this is that Galapagos is surprisingly good at figuring out configurations of these sliders that make Grasshopper's components just not work properly. So what's happened here is we've ended up with intersections here. So it's tried to join together solids that are just oddly too close to each other. So here you can see, you know, these are almost touching, and then these are, you know, somewhat close, and it's just having a bit of trouble figuring out if they're touching or if they're not touching. And as a result, we end up with a 0 volume as well as a 0 area, which automatically makes this the best solution, because we end up with here for working solutions. We'll click reinstate. You see here we end up with a negative number, and we're trying to get as big of a number as possible. So the moment it gets to 0, that's the best it can do. So a glitch wins compared to a non-glitched version. So this is when it becomes important to be the designer and pick the best solution that you think is available. Now, for anyone who's interested in automatically fixing and weeding out this kind of thing, I've actually made another model that adds another little part to this fitness function here. And no, you don't have to do this sort of thing, but I'm just adding this in case anyone's interested or wants to know how you would automatically remove this kind of problem in your model once you know it's there. So we'll go to the next one. And here it's exactly the same model with one tiny change, this part here. a failsafe that avoids letting a glitch get the best fitness. So the way I've decided to handle this, I won't show you exactly what this does, but I'll just tell you what it does. The way I decided to handle this is the moment it gets a 0 number coming out of here, I know that there's a problem, that the model has glitched out, because we know that there should be some surface area and some volume for the building. So I've made this little function here myself that checks if this number is 0. If it's 0, then it says make this number, make the fitness this other number, which is actually minus what is it, minus 1000 or something like that. Very, very small number. So that means that any glitches that result in a 0 coming out of here are automatically kicked to the bottom of the fitness list because their number is so small. So if we run this again, we should hopefully not see any glitches turn up as the best option in the Rhino viewport. So we'll let the solver do its thing. Oops, hang on, I think I've forgotten one important part here. Yes, I have. Sorry about that, guys. I need to test if it's equal to 0. So if this equals 0, then, so here we've got 0. If it's equal to 0, then we will put out minus 1000 as the result. Okay, so let me run that again and it'll work now. So we're still trying to maximize and start the solver, and now we're seeing no zeros turn up as the best possible result. So I'll let that run for a few generations, and that should be a good enough example for that. So you'll notice as well that now that the model's gotten a little bit more complex, and that we've got a slightly more complex fitness function, it is actually taking a little longer to get through every generation. So that's one thing to keep in mind. If your model is a very slow to process model, one generation, which is 50 different slider setups, will take a very long time to get through. So a good way to test if it's going to take a while is just change one of the sliders in your model and then see how long it takes for Grasshopper to figure out the change and then show it in the viewport. And as long as that takes, multiply that by 50, and that's how long one generation will probably take. So yeah, for a lot of people with very, very complex models, you might just want to hit start solver and then walk off for about half an hour and come back and see about 10 or 15 generations that have passed. Hopefully it's going to find a good solution soon. I think we'll just stop it at 15 because it's taking a little too long to get there. So we'll let it get to 14. And it's showing no signs of finding a better solution than the one that it's currently got. So remember, we are trying to get less volume and more surface area. No, sorry, more volume and less surface area. That was the wrong way around. More volume and less surface area. Okay, I'll click Stop Solver now. So now we can jump through our different configurations, and you'll see, like I said, it ends up with some very vastly different solutions when you end up with a very complex model. But what you'll find is, if you let the solver run long enough, say up to about 100 generations, you'll probably end up with one or two kinds of solutions. So maybe it would end up with like one little bunched up thing like this, and then the other one would be more let's see, where's another, more spread out and, you know, squashed down like this. Let's see if there's any other nice configurations. So this is exactly what you'd be doing to click through it all. And then, like I said, here are all of our invalid results right down the bottom because we made it a very, very small number. Because, by the way, if we were trying to minimize, we would make sure that these are getting a very large number, just so that they don't end up being the solution that Galapagos thinks it's looking for. Now I've got one more final example to show you guys, largely to just show the variety of things that you can come up with. So here, let me first of all explain what this component is here. It's a little thing that the Grasshopper team have actually only recently added, and it goes hand in hand with Galapagos. What it is essentially a collection of sliders, and they effectively work as like a group of sliders together, and you can do things like right click, edit, change the number of genes in it, so you can go up to 8 or 58 or whatever. Click OK, and then it adds that many more sliders. Let me put it back down to 6. And yeah, it can be kind of handy, but really I think you guys would be most interested and most interested in using normal sliders, because this kind of thing won't let you easily vary like the width and the height of things separately. You'll have to do something like access a list and grab the first element of this list and then the second element for the width, and it gets a little bit too fussy when you could just be using sliders. So I've just largely made this as a demo of the kinds of things that Galapagos can do. So what I'll do here is I'll right click and go randomize 100%, and that just totally changes all of these values. And I guess the next thing I should do is quickly explain what this example is doing. I'm taking this string evolve, and I am trying to make these sliders here produce another string, because the way computers represent strings and letters and stuff is actually with numbers. So I just convert those numbers into a string. So you can see I'm like varying the first letter and then the second letter, third, fourth, fifth and sixth. So what I'm doing is I'm letting Galapagos control these numbers here and slightly change them over time until this random jumble of letters here becomes the word evolve. So I'll just show you that as a final thing. So we want to minimize fitness because I'm measuring the total distance, just how wrong this is. The more wrong this string is, so the further away this letter is from this one, and so forth all the way down, the bigger the number is. So we want to minimize that number. Now I'll click Start Solver. And we'll see here that, again, the genes are jumping around. And we've got this as all of the possibilities that Galapagos is trying, showing up here in this text panel. And the best option is showing up here. So I'll just I'll stay quiet for a little bit and let it run its course, and you'll see that it will eventually work closer and closer to have the same solution. And by the way, I also set it up so that the two boxes, the one down bottom and up the top, both have colors showing you just how similar these two solutions are. So if you've got a white here and a black there, then they're very, very different. Whereas if it's two similar grays, then they're very close. So I'll just let it run its course here. And you'll notice as well that, it sometimes ends up with, a V there and an L there, but then it jumps away. That's kind of how Galapagos works. It changes one value, but then it also tries to change all the others at the same time, just by a tiny, tiny amount. So if it ends up finding a better solution where all of these letters, like maybe 3 letters, are much closer to the ones that they want to match, even though this one was right to begin with, it'll jump away, as long as the penalty for that isn't as big as isn't bigger than the reward for getting 3 right. So we're sitting on V, L, V, E is correct. Oh, and there we go. All jumped together and correct. Alright, so that's the I guess that's the video, and hopefully we'll be able to get a lot of cool stuff happening in Galapagos in these classes. Alright, thanks for watching.